Now, I want to finish off these slides hopefully this morning. And don't know if any of you have managed to work your way through this lab here. Hopefully you've gone partially through it. There are some features of the Docker desktop that we haven't covered that are included in this lab. So if you have managed to complete the lab, then you're slightly ahead of the lectures, but that's okay. And maybe this week as well, we'll get to work through this lab. So this morning, as I said, I want to finish off these slides. Don't know if I'm going to get into this set of slides here. If not, then I will probably take the first hour and maybe hour and a half of tomorrow morning to walk through these slides. We'll see how we get on anyway. Just in case there are any questions that people have for me specific to the topics that we're covering or something about the module more generally? No? Okay. So back to basics. What we know about Docker in general is what we know is that there are these two kind of concepts. Really, there are only two. Sorry, no. There this notion of an image and a container. So an image is a packaged version of your application, whatever it is. And within that package is your application code, any third-party dependencies that it relies on, any configuration files, any operating system utilities and libraries. Everything that it needs to execute is within an image. And we often refer to as an image as a kind of a template. A template for what? It's actually a template for what is called a container, which is the second concept or construct. And a container is simply a runtime environment for an image. So a container runs an image. And it's as straightforward as that, I guess. We looked briefly at, we focused in then on Docker as being the dominant container engine technology that's available to us. And we talked a bit about the architecture of Docker, so I'm not going to go over that again. In terms of just using Docker then, everybody at this stage has installed Docker on their local machines, and the installation was via an application really called Docker Desktop. And once you install Docker Desktop, you start up the Docker engine or Docker server, also referred to as the Docker daemon. And once you have the Docker daemon running on your laptop, you can then communicate with it either via the CLI, which is using the Docker command, or in the case of Docker Desktop, we have a nice GUI available to us. And I suppose, in fairness, one would tend to use the GUI more than the CLI when you are using Docker Desktop. But there will be scenarios where you will be using Docker not having a GUI available to you. So as I mentioned the last day, it's probably just worthwhile familiarizing and using the Docker CLI just to get familiar with the commands. And so typically the very first thing you would want to do with Docker is to run a container. And how do we do that? Well, we use the Docker run command, and everybody hopefully has done that by now. And the simplest form of the command is what you see there. You just go from the command line anyway, you go Docker run, and then the name of the image that you want to have executed within the container. The image name, if that image is already available to you locally on your local machine, then the Docker engine will simply start up a container and load the image into the container. If not, it will download it. Where does it download it from? Well, it depends on what Docker registry you wanted to download it from. If you haven't specified any registry, then it will assume that it is the Docker Hub registry that it downloads it from. And so it downloads it, and then it starts up your container and it executes the image within the container. And what execute means depends on what is the image. In the case of this image here, HTTPD, it's a simple web server. So it starts up a web server inside your container. And everybody has done that at this stage. If you don't want to run an image, you just use Docker pull. That will just download the image and won't start up any container. And I talked about the fully qualified name for an image the last day as well. So we've covered that stuff already. If you want to get a list of the images on your local machine, this is the command. But of course, as I said, quite often when we're using Docker desktop, we just cheat and we go over to the GUI and just bring up images here, and we have our list of images. So either or. Tagging is something that we will do later on. So for now, all we can say is tagging means creating an alias, an alternative name for an image. And we can't really make any sense as to why we might do that right now, but there are certain cases where you must do that. You must tag an image before you can do other things with it. Now, unfortunately, the word tag has two meanings uh, in the case of Docker. Tagging here, we can use it as a verb. It means to create a copy of an image and give the copy an alternative name. We also use tag. If I go back to if I go back to here, we use tag here as well in the actual image name. Well, when we use the word tag in relation to an image name, tag there means the version number of the image. It's a pity they didn't come up with two different meaning or two different actual words, but so tag has two meanings, but for now, I suppose up to now, tag will mean the version number of a particular image, which means we can kind of ignore this for now. Strictly speaking, if you want to delete a container, you first of all have to stop the container and then delete it. So what I mean by that, let's actually do it. Let's just start up a container. Boom, boom. Let's just do it this way. Docker run HTTPD. Now I've got this image already downloaded, so it'll start it up straight away. Or will it? I got that the last day as well, didn't I? Oh yeah, no, so the image is running actually. Let's confirm that. There's the image. Sorry, here's the container with a kind of generated name for the container. And okay, the container is running, which is good. Now, if I want to delete this container, now I can do it from here, right? By just selecting it and going delete. But from the command line, what you've got to do is you've got to stop the image first. So because now I'm running the image in foreground mode, I'm just going to open a separate integrated terminal here for myself. So I'll just start up another terminal. Now if I go Docker PS for the list of all running images. I think it has actually it has exited the image. Did this the last day as well for me, and I didn't debug why it did it. My guess now is that the image has exited at this stage. Yeah, I don't know why it's doing that actually. Let's just pretend now I'm not doing what I'm actually going to do. Let's go back and try and start it again. I should read the error there now, but I'll just kind of cross my fingers and hopefully that's better. Let's go back to here. Let's go Docker PS. There's my image. Here's the name of the image. Let me just give myself some room here. So I first of all have to go Docker stop, followed by the container name. I can either give the container name or the container ID. It's either or really. Here's my name. And then I can remove the image. That's the kind of way you do it from the command line. Just RM. Now the image is gone. And if we do a Docker PS, even PS minus A for all containers running and exited ones, then we can see that the image is no longer, or the container, sorry, is no longer there. Like the GUI actually allows you to delete it in one step, if you like, by just selecting the container and clicking delete, which will pop up here. Okay, it's not a major point. Boom, boom, boom. Oh yeah. Now we're running, we're creating a container there by just doing Docker run and the image name. But there are lots of command line options that we can use when we're starting a container. And I'm listing the most popular or most commonly used ones down here. You can give your own custom name to the container. If you don't, then the Docker daemon will generate a random name for you. You can run the container in background mode, which is really what you would do in most cases. Up to now, we've been running it in foreground mode, but the -D um, means run it in background mode. If the application running inside of the container, um, if the application is using a TCP port to receive requests, uh, then what we can do is we can now, of course, the port is linked to the container. We can link that container's port, TCP port, to a TCP port of our host, of our laptop. And in that way, then we can actually communicate with the application running inside the container from our host. The P there kind of stands for publish. You can publish a port of the container. You can publish it to the host machine, if you like, and that's something that we do quite a lot. In many cases, there are environment variables that some of them are optional, some of them are mandatory. But if we want to set environment variables which the application inside of the container needs or uses, then the way we can set values for those environment variables when we start up the container is using the -e option, and we will use that a lot. The -v option, what that allows us to do is to have a folder on our desktop, which is the host, and make the contents of that folder available to the application running inside in the container. So what we say is that we bind or mount a folder or a volume, which is what the V stands for. We bind a volume of the host and bind it to a particular path within the container image. And that's something that we will do quite a lot as well. The -rm option is what that does is when you stop a container, then it removes the container automatically. So what I was doing there a moment ago was I was stopping the container and then I was removing it as two separate commands. But if you start the container with the -rm options enabled, then all you've got to do is stop the container and the Docker daemon will automatically delete the container or remove it for you. So that can be useful. The -it option is something that we'll use again also, as you'll see. It, it really kind of allows you to create a terminal session with the container itself, which can be very useful. The minus restart, I don't use that often, but you can specify kind of a restart policy if a container happens to exit. So let's, and again, in the first lab, you've actually played with these if you happen to have walked your way through the first lab. So if we go back to here, and if I now go, I clear up my terminal first. And if I now go Docker run again, I was playing with this earlier, so rather than type it all out, let's take this one here, right? So I want to run a container, and again, I want to run the HTTPD web server inside the container. I want to give my container this particular name rather than let the Docker engine randomly generate a name. I want to run it in -d in background mode. Now, the container, the image inside the container, I know is running a web server, and that web server is listing on port 80. But I can't simply go localhost 80 and expect to be able to communicate with it. In fact, let's try and do that. All right, if I take out this option, okay, so first of all, the -d worked because I now have the terminal prompt back straight away. This is just a kind of an identifier for the container that has started. But I do know my container is running. If I go docker ps, yeah, so the container is running, and it indeed has given the container the name that I asked it to over here. And as I said, I've looked up the documentation of this image and I know it's running a web server listing on port 80. So you might think, well, if I just go localhost 80, I should be able to get at it. But take it from me that you can't. Maybe you don't believe me. If I just bring up a tab, my browser, go localhost 80. No, there's nothing running on port 80 on this machine, so that didn't work. That's where the port forwarding comes in. So Just for the heck of it, I'll actually start a second container. I'll call this one Web 2. And this time I will use this port mapping as it's referred to option. So -P, and I'll just use port 3000. I'll explain this in a second. :80. So the way you interpret this is you want port 3000 on the host machine to be bound to port 80 of this container. And so any requests that are sent to port 3000 on the host machine, in other words, localhost 3000, those requests will be directed to port 80 of this particular container, And of course, the web server running inside the container, it is listening on port 80, so it will ultimately receive that request. Let's hit return. I now have, let's do the Docker PS again. Okay, I've got two containers running. They both happen to be running the same image. That's no problem. But there's kind of further evidence. Where is it? Let me just delete that there. This kind of stuff here tells you about the port mapping, as it's referred to, that you may or may not have set up. And in this case here, we have set up a port mapping from port 3000 to port 80. We don't have any port mapping here. But if I now go to my browser, and if I go localhost 3000, hopefully, no, that's not what I should get. I'll just do a refresh. Okay, so the it works, that's the response. The response that I got there a moment ago was actually something that my browser had cached from some playing around that I was doing earlier on. So this it works is the sort of the home page of the Apache web server. That's my HTTD web server. It's the Apache web server. This is the home page, the default home page of the Apache web server that's running inside in my container. So I'm now communicating, or I'm able to send requests to that web server. So that's what port forwarding allows us to do. Obviously, it only works if the application that's running in the container is listening on a port. Otherwise, it's of little use to do any port mapping. So we've demonstrated these three here. Let's see, what's this talking about? The other thing we could do is to maybe use this option here. So I've got a web server running inside in the container, and it has an index.html, a default index.html web page. Could I get it to use a different web page, maybe from my own host machine? Is that what I want to do next? Let's see. Am I jumping too far forward? Yeah, okay, let's try that. Now, let's see. So I have a web page here. So I've got an index.html. Just pull this down a little bit. Okay, and I could have other HTML pages within this folder, so that it could be an entire website. It just doesn't have to be a website. But I'd like my Apache web server running in the container to somehow access this folder here, which is external to the container, obviously. How do I do that? And the answer is, well, you bind this folder to the folder that the Apache web server uh, looks at inside in its own image. Now, how do I know what folder the Apache web server uses inside in its own image? You know, what path name to the particular folder within the image does it use to access its website? Then I would really have to look up the Apache web server and find out, well, what is the path name within the uh, within the image that the Apache web server uses. I'd obviously have to try and discover that. And, the way you would maybe do it is you'd actually go on to Docker Hub, uh, find the image. You can do a search here, find the image, and I happen to have it here, right? And then, just read the documentation. Now, I did that, and what I discovered is, what did I discover? I've put it somewhere now. Oh, is it? Let's see. What I discovered is this is the path name within the image that the Apache web server uses. So if I could actually look at that path name within the container, and we'll do it in a minute, we would find that within this path, there is a file called index.html, and that index.html contains very simple HTML, and what the HTML generates is this, right? So what am I trying to get across to? Well, maybe if I just do it, I'm going to may as well run a third container. Maybe I'll just clear this first. And I'm going to add the -v option, and that's going to allow me to bind a folder on my host here. Now, the uh, the relative name of this folder here, this website folder, is contained within a parent folder called containerization, and that's contained as a subfolder of where I currently am here. So if I go // containerization / okay, maybe if I just finish it and then explain it. So the way you interpret this here now is take this folder here from the desktop. It's a relative path name. The colon, and what follows the colon then is the path name within the container itself. And so I'm binding this folder, I'm binding it to this path name. So whatever the contents of this folder is, that contents, which we can see on the left there, is just one HTML page. The contents of that folder is now going to be accessible to my container if it uses this path name here, if the image, the code within the container uses this path name, anytime it uses this path name, it's actually going to be accessing the files contained in this website folder. Uh, I've got to give it a different name now because I can't have two. So I'll give it number 3. I also have to use a different port because port 3000 is already being used. Oh, where's my port here? So I go 3001. And if we just see the end result first, if I now go localhost 3001, okay, that is the actual web page that I showed you in my website folder. So the container is now kind of reaching outside of its environment uh, into my file system, into the host file system, and it's just using the contents of that folder. In this case, because it's a web server, it's rendering the HTML. So that's what's known as volume mounting or volume binding, and it's something that we'll come back to again later on if you're a little bit unclear or if I haven't explained it clearly enough to you. There's nothing new here, I don't think. Now, this is a really important thing to grasp. So I've started up a container, and is there a way I can actually get inside the container to typically do some debugging? And the answer is you can actually. You can get at it from the outside using this docker exec command. So at the moment now, we've got 3 separate containers all running the same image, and that's okay. So if I go back to the very first one, this my web, okay, and let's try and get inside that container using this docker exec command. So the format is docker exec, and all of this. Okay. So let's try it. Docker. And again, you can see I was playing with it earlier on. So it's docker exec. The -IT means you want to start up an interactive terminal. Then you specify the container name, which in my case is my web. We're just picking that one arbitrarily. And then you specify the type of shell, Linux shell you want to start up this Docker exec session with, if you like. As you know, all of the images that we will be working with are Linux based. So this is the Linux shell that I want to create when I start up this interactive session. So I just hit return. Doesn't work. Why doesn't it work? Oh, I see. Typo. Is that the problem? Right. Now, see, my prompt now has changed. And really now this prompt is the shell prompt inside in my container. I'm now inside the container. So if I do ls, or maybe pwd if you remember your Linux commands. Pwd is print working directory. In other words, show me where am I in the file system of this Linux environment. And that's where I am. And the ls showed me all of the folders in the current, the contents of the current folder. Now, what I've already told you is, see this path name up here? I've discovered that that is the default path name that my Apache web server uses to access the default home page. And that default home page, if you remember, it just contained the "it works" header and nothing else. So if I could display the contents of this file within the container, I should get uh, the "it works" kind of content back to me. So if I go, um, let's just go down to the folder maybe. If I cd down to this path name here, again, if you have worked through the lab, you've actually done all of this already. But so I want to cd down into that path within my Linux container. And if I now do ls, show me the contents of this folder. Okay, it has an index.html. Can I display the contents of that file? Cat is the Linux command to display the contents of a file. Cat is in catalog. If I do cat index.html, and lo and behold, it works in as a header is the simple contents of this index.html file. And that's exactly what I got when I sent a request to, was it the MyWeb2 image, the MyWeb2 container. The MyWeb2 container doesn't have any um, volume mounting associated with it. The MyWeb3 was the one that had the volume mounting. Let's exit out of this one. And if we go into, if we start up a session in MyWeb3, now MyWeb3 is the one that has the binding to the folder on my host machine. And so if I now do the exact same thing as I did with my web, if I do cd down into this folder here, or this path, okay, so I'm now inside in my web3, inside in that container. It's running the exact same image as the other two containers. We looked at one of those other containers. We went inside it and we did a cd down into this path, and we did ls and we found an index.html and we displayed the contents of that index.html, and it showed us that it just has a single it works. If I do ls this time, okay, there's an index.html. If I cat index.html, oh, getting something completely different. What am I getting? What I'm getting here is the contents of this index.html over here on the left. And if you're still a little bit, if I here on the left, if I create a new file, doesn't matter what it is, I call it test. It doesn't matter what type it is either. Test.txt, let's say, txt. And I'll just put any old gibberish into it. Let's not put gibberish. Let's say hello world. Save that. Go back to my container. Now, where am I? I'm still inside in this folder. If I now do ls, here's text.txt. So that's just, I'm trying to confirming to be sure, so to speak, that this folder within the container, what folder? This folder here within the container is bound to this folder out on my desktop. And that's kind of been confirmed by the fact that, look, it found the text.txt. Notes, there's notes in there as well. Oh, it is actually, yeah. So there's 3 files. Okay, I'll pause for any questions, but no. Right. So we've done the exec. We've actually got inside. Another useful thing when you're debugging is to just look at the logs generated by the application running inside in your container. Okay, so that's something that you do externally. That can be very useful as well for debugging. So these 2 commands here, the docker exec one and the docker logs one, they are mainly for, as the kind of slide heading suggests, they're mainly for kind of debugging, or mainly used when you are debugging. Sometimes you won't be able to use docker exec because if the container is exited, you can't, as we say, you can't docker exec into it. You can only docker exec into a container that is running. Can I prove that? If I exit out of this first, and if I stop, let's stop just my web one. Yeah, let's do a docker stop. Now if I try and exec into that, I hope it doesn't make a mockery of me now. If I exec into my web, it doesn't allow me to do it because the container is not in a running state. And that can happen too, like if the image, let's say if it's your own image or if it's an image of your own application and your application is currently buggy, when you try and start a container and it tries to run your image and your image crashes because there's a bug in it, then you can't use Docker exec to try and debug what's gone wrong. In that case, all that's available to you is Docker logs. Is it log or logs? I'll just go my web. Doesn't really matter which one I pick. Okay, so this is all the logs that was generated by the uh, Apache web server in our case. Okay, I think that's the last one in this set of slides. Yeah. Okay, rather than trying to push it now, I'm actually going to stop here. And then if I go back to the website, tomorrow we will look at this. We'll start looking at these slides here where we talk about networking within Docker, which is also a very important part of the whole Docker environment. We're kind of running containers there, and each container is separate from every other container. But in real life, what you will have is containers that need to communicate with one another. And how do we communicate? We communicate across a network. But fortunately, we don't have to go creating the networks. Docker will create them for us. So that's kind of an interesting part of uh, the Docker environment. Okay, I'm going to stop here. It's kind of early for me, really, but that's okay. I'll pause just in case there are any questions before we wrap up. No? Okay. So I will talk to you again tomorrow morning, and also then you'll get a chance to certainly finish off this lab. And depending how far we get in the slides, you may be able to start into this one too. Okay, talk to you tomorrow morning. Thanks. Bye bye.